Okay, so question 3, even though it doesn't look like a projectiles question and it doesn't start off as one, we can still use a SUVAT at the beginning here. So let's write down what we know. So SUVAT. So we know that the ball travels 1.3 meters. Its initial speed is 1.8 meters per second. We're trying to find its final speed, so I'll label that with a question mark. And it's decelerating, so I'll label it as minus 1.2 meters per second squared. We're looking for V. We've got US and A, so V squared equals U squared plus 2AS. So V equals the square root of U squared plus 2AS, which equals the square root of 1.8 squared plus 2 times minus 1.2 times 1.3. This is going to give us a final answer. I need a calculator. So 1.8 squared plus 2 times minus 1.2 times 1.3 square rooted gives me a final answer of 0.35 meters per second. Okay, the golfer hits the ball, hits it at velocity u, 35 degrees. We know the horizontal component of u is 8.8. So what we know then is that it's hit at u at 35 degrees. And we know that this value here is 8.8. But this is also u cos 35. So let's work out what u is. So u cos 35 is equal to 8.8. So u is 8.8 over cos 35. That is 10.7. I'm going to keep the full number on my calculator because we want the vertical component. So the vertical component would be u sine 35. You want to label it something, you call it u vertical, is u sine 35. So take our answer, times it by sine 35, and we get 6.16 meters per second. Okay, so we showed it's about 6. Traveling horizontally as it reaches x, as shown. Now, this is a trick here. A lot of people miss this. It's traveling horizontally. So that means that there's no vertical velocity. And we can use that when we solve here. So we're going to calculate the time for it to get to x. So let's see what we can write down. Let's write down a horizontal SUVAT first. S-U-V-A-T. So what do we know? Well, we know its initial speed is that value from further up. It was 8.8. So it's going at 8.8 meters per second. Do we know anything else? Do we know how far away it's gone? No, I don't think so. Do we know its acceleration is 0, but that doesn't really help us. Let's write out verticals instead then, S-U-V-A-T. We know that this vertical is about 6. I'll use 6.16 meters per second. And here's the trick. If it's only traveling horizontally, then its vertical velocity at this point must be 0. Acceleration due to gravity is minus 9.81. Again, I've chosen upwards as a positive direction. And we need to find time. We've got 3 things, we need a 4th. V equals u plus AT. Let's make t the subject. T equals v minus u over a. So 0 minus 6.16 over minus 9.81 comes out to give me 0.63 seconds.